Hi, I'm Jeremy, and I built this. So whenever you're working on a project, probably budget is one of the biggest concern. Like if you want to work on a project like this, you have to spend at least $1,000 to make it really look good and perform really good. So in a nutshell, it's really costly project. So the point is, I wanted to build an automatic piano, and here it is with about $300, and I'm happy with it. Now before I move on to explain how the hardware and the system kind of works, you need to know what MOSFETs are and what shift registers are. If you don't know what they are great videos on YouTube. You can go ahead and search how MOSFETs work. In this particular project, we are going to use N MOSFET, which I believe is the most used MOSFET anyway. And for shift registers, there are also very good videos out there too. I myself didn't know how to use a shift register before this project, so you can check them out. Alright, to start with, we've got a piece of plastic. That is basically the frame of this entire project. Our solenoids goes on that, our wires goes on that, and our board goes on that. Now solenoids are solenoid, that's just it. And I placed little sponge kind of thing on the top because apparently when these solenoids hit the keys, it makes really loud noise. Even without that, even with that, it makes quite a lot of noise. So without it, it just isn't. You really can't hear whatever the piano is playing. So I decided to put a little sponge thing over there. This board consists of 595, 74HC595 I believe, and 8 MOSFETs. They are all connected from 595 to 595 and 5995. 55595. God damn it. The naming still, these chips though. Yeah, it basically sends 8-bit data from here to the next one. So eventually eventually on the computer, what computer will do later, you will have 11 sets of 8-bit data that just pushes into this entire set. Oh yeah, you probably have noticed if you are an engineer that I don't have resistor on the MOSFET, and the reason is, first of all, I can't mention that I forgot to put it. Second of all, I don't think I really needed it because I did a test. I don't think these MOSFETs do close pretty well without pull down resistor, so I decided to not put it. Of course, it's not a proper engineering. Of course, it's not the best idea. It's a bad idea. Don't do that if you're an actual engineer and building something like that. And of course, the most important part, we've got an Arduino. Now if I were to use an Arduino Mega, I can build this without shift registers and all this messy stuff with just 2 Arduino Mega. But as I mentioned, this project is really budget centric and I can't afford 2 Arduino Megas. That's why we have 1 Arduino Uno and 11 shift registers. Now when it comes to power, I forgot to mention that these solenoids are rated at 12 volt and 5 Newton. Let me see if I can get that on the camera. 12 volt 5 Newton at 300 milliamps. It wouldn't require 5 Newton to just push on the key like this, but it will require more than that if I were to push from the innermost part. So it turns out 5 Newton wasn't enough for these solenoids to push these keys. I needed to double the voltage and it worked totally fine. The only problem with that is it heats up pretty fast, and I glued these solenoids with hot glues, and apparently hot glue is melted at about 80 Celsius degree. So when these MOSFETs get hot, they will fall off. Now that problem's been fixed with these double-sided tape. They are specified to be able to handle up to 150 Celsius degree, and that should be just about enough to keep them on the plastic plate. So when it comes to power, I have multiple options actually. I could get a really giant 12 volt power supply or a single 24 volt power supply. Either way is going to be expensive. These solenoids, each one of them will consume 24 volt 600 milliamps in theory. And if I were to imagine, say I'm pushing 10 keys, then there will be about 600 times 10, so there will be 6 amps. 24 times 6 amps, and in some cases I might use more than that. And technically speaking, solenoids are short circuit, technically. Therefore, I need really large power supply. Well, as I mentioned, that this whole project is budget centric. That's why I stored my dad's car battery. Swedish do make stuff properly. They should provide enough power to all these solenoids. Alright, so that's the entire tour of the hardware, and let's move on to the software. And software part is really going to be kinda ugly, because when you don't have enough hardware and try to get one single hardware to many things, usually the software part gets really messy. Software part really consists of multiple steps. First, you get a MIDI file, and you need to convert the MIDI file into a text file, if you know what that means. It means if you have a MIDI file and you try to decode this, then you get a hex file, which is kind of like a secret words for telling you what this is and what that is. So for me to work much easier, it's better for me to see a note saying, well, that hex is this and that hex is this, instead of just trying to show what the hex is. So when you have the MIDI text file, you're going to convert that into a what was it? 8-bit binaries. Yeah, that is binaries. So eventually you're going to have something like, you have a time and you have a set of 11 set of binary 8-bit information for that time to be sent to the Arduino to be executed on the piano, if that makes any sense. So this is a binary MIDI to text conversion site. What you can do, you can choose a MIDI file and then send it to the server. It will give you a text file like this. Now, ignore time signature, tempo, and whatever it says that is not on and off. You might be a bit worried at this point if you're a musician, because ignoring tempo is never a good idea. I gotta tell you, later we are going to multiply by a tempo multiplier, and that should do just right job. Anyways, copy these data into a text file, and apparently you will have a file like this. Now, take this file and run through my Python code, which will be available through Hackster.io if you are interested in running through this, or if you want to just take a look. You can go ahead and go to the Hackster.io. The link is in the description, and then eventually you will get something like this. So these are basically time on the left and 11 sets of 8-bit data on the right. Like I mentioned previously, shift registers take a data and then sends to the next one once there's new data, and then if there's a new one, it sends the entire thing to the next shift register. So if we just pump that data into the shift registers, bam bam bam, then we'll get boom, one set of I don't know how to say, play. Anyways, once you have that, the hard part is really over. You just have to send these data through processing. But what it really does is nothing more than just take this file and I send this data by data at right time. That's what processing does, and Arduino just takes it and they send it to the shift registers. So yeah, that's really it for this video. Thanks for watching. Oh yes, I almost forgot the most important part. The naming. Now, automated piano sounds pretty good. Awesome. But I thought of something else. Something simple, something short. Because it's piano playing robot. How about PiBot?